Hydraulic systems are comprised of three basic parts: a master cylinder that pushes fluid through the lines that carry the fluid, and a slave cylinder that moves when fluid pressure pushes upon it. Master cylinder is the heart of the entire braking system. Master cylinder stores brake fluid and converts the motion of the brake pedal into hydraulic pressure. Most master cylinders are manufactured of cast iron or aluminum, and contain brackets with holes for mounting. The master cylinder is connected to the brake pedal via a push rod. Single piston master cylinder consists of reservoir, cylinder body, piston, and return spring. The rubber seal of reservoir cover allows for continuous pressure to be placed on the fluid, preventing the chance of a vacuum to build inside the master cylinder reservoir. Single piston master cylinders have one piston with two cups, a primary cup and a secondary cup. These cups are also known as seals. When force is applied to the piston by the push rod, the primary cup seals the pressure in the cylinder, while the secondary cup prevents loss of fluid past the rear end of the piston. An inlet port connects the reservoir with the space around the piston and between the piston cups. A compensating port connects the reservoir to the cylinder, just barely ahead of the primary cup. An outlet port links the cylinder to the brake lines. The compensating port adjusts for changes in the volume of the brake fluid ahead of the piston. This occurs due to the expansion or contraction of the brake fluid as it heats up or cools down. As the push rod from the brake pedal moves the piston forward, the compensating port is closed off, trapping brake fluid ahead of the primary cup. Fluid trapped in the cylinder is then forced from the master cylinder outlet port into the brake lines. When the brakes are released, the master cylinder piston returns to its original position by action of the spring. When the piston fully returns against its stop, the primary cup uncovers the compensating port. Fluid ahead of the primary cup can now return to the reservoir. When the brake pedal is released quickly, the piston returns back quickly, but the brake fluid cannot return as quickly to the cylinder, creating a low pressure area ahead of the primary cup. To prevent vacuum from being created, fluid can pass from reservoir into the working chamber, through the inlet port and small holes drilled in the piston land and around the primary cup seal. This is called recuperation. When the fluid in the lines returns to rest, its pressure is held slightly above atmospheric pressure by a valve called the residual line pressure valve located at the outlet end of the master cylinder. The residual pressure helps stop air from entering at the wheel cylinder, and it keeps fluid from leaking out. The tandem master cylinder has two separate hydraulic chambers. This creates in effect two separate hydraulic braking circuits. If one of these circuits becomes inoperative, the other circuit can still function to stop the vehicle. Rubber boot for master cylinder push rod prevents dust, dirt, and moisture from entering the back of the master cylinder. The master cylinder consists of the reservoir tank, which contains the brake fluid, and the pistons and cylinder which generate the hydraulic pressure. Reservoir tank stores an extra supply of brake fluid, cast as part of the housing or added as a removable plastic part. The reservoir diaphragm lays directly on top of the brake fluid, which helps keep air from the surface of the brake fluid, because brake fluid easily absorbs moisture from the air. There can be two separate fluid reservoirs for the primary and secondary chambers. A tandem master cylinder having a single reservoir tank has a separator inside that divides the tank into front and rear parts. The two-part design of the reservoir ensures that if one circuit fails due to fluid leakage, the other circuit will still be available to stop the vehicle. The tandem master cylinder has a single bore separated into two separate chambers by the primary and secondary pistons. This creates in effect two separate hydraulic braking circuits. Both piston assemblies rest in the cylinder. Primary piston assembly is retained by a snap ring in the end of the cylinder, and secondary piston assembly is retained by a stop plate. Pistons and cups are used to pressurize the system. When they are pushed forward, they trap fluid and building pressure. Primary piston is acted on by push rod. At the front of the primary piston is a rubber primary piston cup, which seals the primary circuit of the cylinder. And at the rear of the primary piston is a secondary piston cup, which prevents the brake fluid from leaking out of the rear of the cylinder. The inner piston head has several small bleeder ports, that pass through the head to the base of the rubber primary cup. Secondary piston is acted on by hydraulic pressure, generated in primary circuit when brake is applied. At the front of the secondary piston is a primary piston cup which seals the secondary circuit. And at the rear are two secondary piston cups, which seal the secondary chamber cylinder from the primary chamber cylinder. Each piston of the master cylinder has inlet port, compensating port, and outlet port. The intake port is the low-pressure rearward, larger diameter, straight drilled hole which is always open to the reservoir. The intake port is also called replenishing port, bypass port, filler port, or breather port. The intake port allows fluid from the reservoir to fill the low-pressure chamber. The intake port keeps the volume behind the front piston land, filled with brake fluid from the reservoir, as the piston moves forward during a brake application. The compensating port is the forward tapered hole. The compensating port is also called vent port or high-pressure port. It allows fluid to flow into the chamber when the brake pedal is not depressed, and allows fluid to return to the reservoir when the brakes are released. The compensation port also absorbs any changes in brake fluid volume, due to temperature changes. The primary outlet is the outlet closest to the pushrod end of the master cylinder, and the secondary outlet is closest to the nose end of the master cylinder. When the brakes are not applied, the piston cups of the primary and secondary pistons are positioned between the inlet port and the compensating port. This provides a passage between the cylinder and the reservoir tank. When the brake is applied, the primary piston moves forward and blocks off its compensating port, sealing the fluid in front of it. As the piston continues to move forward, it will transmit fluid pressure to primary circuit and to the base of the secondary piston. This causes the secondary piston to move forward, block off its compensating port and apply pressure to the secondary circuit. When the brake pedal is released, the pistons are moved rearward by hydraulic pressure and the force of the return springs. As the pistons start to move outward in the cylinder, they will move faster than the fluid can return through the lines. This creates a mild vacuum in the pressure chambers and fluid will flow through the bleeder holes in the head of the pistons. This fluid will bend the lips of the cups away from the cylinder wall, and fluid will flow into the cylinder ahead of the pistons. This action also allows brakes to be pumped up, that is the repeated application of the pedal in quick movements. As the pistons return to their fully released position, the primary cups uncover the compensating ports and any excess fluid will flow into the reservoir. If there is a failure in the secondary circuit, the hydraulic pressure in the primary chamber easily forces the secondary piston to the left, compressing the return spring. The secondary piston advances until it reaches the far end of the cylinder. The primary piston will then apply normal pressure to the primary circuit. If the primary circuit fails, additional pedal movement will cause the rod attached to the front of the primary piston to mechanically move the secondary piston forward, transmitting normal brake pressure to the secondary circuit. Lockheed Type master cylinders use a compensating port on both the secondary and primary circuits. A new style master cylinder is used on late model vehicles equipped with ABS and ABS traction control. A portless ABS master cylinder design does not use a compensating port on the secondary circuit, so there is non-restrictive single passage from the reservoir to the secondary piston. The primary piston still uses a compensating port and an inlet port. The secondary piston provides a machined passage to the secondary circuit which is controlled with a center valve that controls the opening and closing of a supply port drilled into the piston. This supply port replaces the compensating port in a normal master cylinder. Portless cylinders utilize a valve assembly in the pistons that opens to equalize pressure when the brakes are released. At rest position, the supply port is open and connects the reservoir with the secondary brake circuits. When the brakes are applied, the primary piston moves and closes its compensating port. Brake fluid pressure in the primary circuit rises and acts with the primary piston spring to move the secondary piston forward. The secondary piston moves and the center valve closes the supply port. When the piston moves further, hydraulic pressure is created in the secondary circuit. When the brakes are released, the springs in the master cylinder push both pistons back. The supply port is open and thus the center valve creates a passage between the valve head and the secondary piston. Through this small passage brake fluid can flow back to the reservoir. Portless ABS traction control master cylinder design does not use a compensating port on both the primary and secondary circuits. Each of the primary piston and the secondary piston have a center valve. Brake hydraulic components are connected by a network of seamless steel tubes and hoses, which transfer fluid pressure from the master cylinder to the wheel brake assemblies. The brake lines are made of double-wall steel tubing, with copper plated and lead coated to prevent rust and corrosion. Each end of brake tubing is a double-lap flare, and fitted with a flare nut. The tapered seats and double flare tube provide a compression fitting to seal the connection. Single flare is never used for brake line. Bubble flare is for domestic and European vehicles. Double flare is the most common type of brake line's flare. A junction block is used where a single brake line must feed two wheel cylinders or calipers. It is simply a hollow fitting with one inlet and two or more outlets. Rubber brake hoses are used where a flexing action is required. For example, a brake hose is used between the frame and the front wheel cylinders or disc brake calipers. This design allows the wheels to move up and down, as well as side to side without damaging the brake line. Mounting brackets and clips are used to secure brake lines and hoses to the body or frame of the vehicle, to prevent damage from vibration. A wheel cylinder is a component in a hydraulic drum brake system, which is located in each wheel. Wheel cylinder is usually positioned at the top of the backing plate, above the shoes. Wheel cylinder uses master cylinder pressure to force the brake shoes out against the drum, and stop the vehicle with friction. On the back of each wheel cylinder there is a threaded hole for the brake line, and a bleeder valve that can be loosened to bleed air from the hydraulic system. The wheel cylinder is bolted or clipped to the backing plate. The wheel cylinder consists of a cylinder housing, pistons, rubber cups, spring, and cup expander assembly, dust boots, and bleeder screw. The wheel cylinder housing encloses all the other parts of the assembly. It has a precision cylinder in it for the pistons, cups, and spring. Wheel cylinder has two pistons, one on each side. Each piston has a rubber seal and a shaft, push rod, that connects the piston with a brake shoe. The wheel cylinder cups are special rubber seals that keeps fluid from leaking past the pistons. They fit in the cylinder and against the pistons. The expander spring assists in holding the rubber cups against the pistons when the assembly is not pressurized. Cup expanders maintain pressure on the lips of the cup seal, keeping air, dirt, and moisture out of the system. The dust boots keep road dirt and water from entering the cylinder. They snap into grooves that are cast on the outside of the housing. The push rods are held in place by the rubber dust boots. As the wheel cylinder pistons move outward, the push rods transfer the movement to the brake shoes. The bleeder screw is usually positioned to be the highest point on the cylinder. This aids in bleeding air from the system. The caliper is the part of a disc brake that squeezes the pads against both sides of the rotor, when the brake is applied. Disc brake caliper assembly is bolted to the vehicle axle housing or suspension. Brake calipers have two functions in a motor vehicle: they house and guide the brake pads, and they provide the hydraulic actuation. They house and guide the brake pads, that ensures every time you apply the brakes, the brake pads are in the right position to move onto the rotor. Brake calipers provide the hydraulic actuation that converts brake fluid pressure into mechanical movement, that enables the braking action. While there are several designs for brake calipers, the most common type is the floating caliper. The floating caliper has two main sections, caliper bracket and caliper body. The floating caliper bracket solidly mounts to a suspension component with two bolts. The floating section is bolted to two pins called slide pins or guide pins, that let it slide freely from side to side, float. Floating mechanism provides a gap between a brake pad and the rotor, and it includes a sliding pins which are supported by rubber bushings. The mechanism is used to retain and locate floating calipers. The sliding pins are greased and allow for proper alignment of the caliper to the brake rotor, and still allow for the movement needed under normal driving. The slide pin boot job is to keep the water, sand, and dirt away from the slide pin bores, and helps keep the special grease inside. The slide pin reciprocates in the bushing during operation of the brakes, and the bushing moves along the bore as the brake pads wear. The brake caliper body is composed of caliper housing, piston, square cut seal, dust boot, and bleeder screw. The caliper body holds all of the parts of the brake caliper together, and floats to allow both application of both brake pads as well as the ability to release the brakes. Caliper cylinder is a machined hole in the caliper housing. The piston fits into this cylinder. The caliper cylinders have grooves machined into their surfaces to hold seals. The caliper cylinder is connected to the hydraulic brake line system. Floating caliper has one or more pistons, located on the inboard side of the caliper. When the brake is applied, the piston is pushed by the brake fluid to close the gap between the brake pads and the brake rotor. Caliper pistons may be aluminum, steel, or phenolic, plastic. The square-cut O-ring not only seals hydraulic brake fluid, but also retracts the caliper piston when the brake pedal is released. The square-cut O-ring deforms when the brakes are applied, and returns the piston to its original position, released, due to the elastic properties of the rubber seal. The V-shaped groove for the square-cut O-ring allows for more retraction. When the brake pedal is released, the piston is moved away from the rotor farther, resulting in less friction between the disc brake pads and the rotor when the brakes are released. Caliper piston seal flexes in its groove, making it act like a return spring for the pads to provide running clearance. Piston dust boot prevents contaminants, such as dust and debris, from entering the piston cylinder. A bleeder screw lets you remove air from the brake lines, bleed, when replacing the braking fluid or carrying out other caliper servicing tasks. The bleeder screw seals at the bottom of its bore. The fluid passage in the middle of the screw reduces its strength, making it easy to twist off.